If you can hear me online, sorry about the technical difficulties. We ran into a little problem at the last minute with the slides. Avi's going to go ahead and start without them. Let me just take a minute to introduce him a little bit. Avi is the Rotman Chair in Artificial Intelligence and Healthcare and a Professor of Marketing at the Rotman School of Management at the University of Toronto. He's also Chief Data Scientist at the Creative Destruction Lab and a faculty affiliate at the Vector Institute and the Schwartz Weitzman Institute for Technology and Society, and a research associate at the NBER. His research focuses on opportunities and challenges in the digital economy. And today he's going to be talking to us about his new book here. It's along with Joshua Gans and AJ Agarwal, Power and Prediction, and it comes out tomorrow. So please take it away, Avi.
Okay, thank you. Thanks for coming. And as we were getting ready to sort of think through what our next book was, our last book came out in 2018. The hype and excitement around artificial intelligence kept building and building and building. And if you were paying attention, you heard people say things like AI is going to transform the scientific method, it's going to solve climate change, it's going to cure cancer. Since we're in an academic environment, I imagine many of you met those claims with a lot of skepticism. But if any of those claims are even a little bit true, we can expect trillions and trillions and trillions of dollars in the global economy, and maybe solve some of the productivity challenges that we've had over the past decades or more. Now, underlying that hype is really a lot of confusion about what we're talking about when we're talking about artificial intelligence. In the popular imagination, we usually think about it as truly intelligent machines that can do just about everything we humans can do. There might be an optimistic version of science fiction, like we see in Star Wars. You might not think of Star Wars as optimistic science fiction, but the machines in Star Wars are optimistic science fiction because they listen to us, to the humans, or at least the life forms. And of course, the rest of science fiction is filled with these machines that can do everything we can do, but they don't listen to us. I don't think that idea of an AGI is crazy. Eric and I were just talking to someone, recent claim on 2029. That maybe seems a little crazy to me, but soon enough, it's possible. But it's important to recognize that's not the reason we're talking about artificial intelligence, especially in a business context in 2022. The reason we're talking about AI today is because a very particular suite of technologies with machine learning at the center have gotten much, much better. And these technologies, can I get a clicker?
Oh, sorry. You're gonna have to use your computer for that one. I will just follow along with mine on the
okay. A very particular suite of technologies called machine learning, around machine learning have gotten much better. In our first book, we represented this as a drop in the cost of prediction. We're economists. We said we can think about technological change as a drop in the cost of some fundamental input, and we can think about the advances in machine learning and computational stats as a drop in the cost of prediction. And that, the book coincidentally came out in 2018, and so that's where we said we were right on the cusp of transformative change. And so what we started to see in all sorts of applications is people using prediction in ways sometimes that they'd used it before, and in some new kinds of contexts. So we saw prediction, if you want to predict whether you're going to pay back a loan. So prediction and credit. We saw prediction in insurance, right? The insurance industry, they're in the business of prediction. That's what they do. They price risk. And so we've been seeing machine learning tools helping with underwriting in the insurance industry. We've also started to see people develop tools for prediction in medical diagnosis, because once prediction's cheap enough, we start to realize that, what's diagnosis? It's taking in information about your symptoms and filling in the missing information of the cause of those symptoms. That's prediction, right? Prediction, to be clear, defined in the statistical sense, which is taking information you have to fill in information you don't have. And image recognition is prediction. So we started to see big companies applying prediction in all sorts of ways, recommending what you might want. Amazon has hundreds of millions or more items in their catalog, and they provide a prediction about what they think you might want. And then we've seen through our lab lots and lots of startups, different AI startups, thinking through a workflow in a particular industry, identifying certain tasks that are prediction tasks, taking out the human, or perhaps complementing the human and dropping in an AI. Okay. And so as we've seen more and more applications of machine prediction, we've also started to see people say things like AI is more profound than electricity or fire, or AI is a new electricity. That seems incredible, right? Electricity is everywhere. We're in this room with the shades drawn. We can be here and working because of electricity. It seems to just permeate every aspect of our home and our work in the 21st century. But then we look at the data for AI, and we think, how can AI be the new electricity? We have less than 5% adoption in manufacturing, less than 5% in retail, less than 5% in healthcare. This is census data, so it's 4 years old. So in case you think the world has changed a lot since 2018, here's hiring data from 2021. Even in the industries with the most potential excitement and hype around AI, like information, we have something like 3% of jobs requiring machine learning and AI tools. And in many of the most hyped industries like healthcare, we have less than one, something about 1 in 1,000 jobs requiring AI tools. Okay, so we see the hype around AI, and it seems to be extraordinary, but how can it really be the new electricity when electricity is everywhere and AI seems to be, so far, pretty much nowhere? Now, that's when it's time to start digging into the history of electricity. Okay, so dig into the history of electricity. This is what a factory might have looked like in the 1880s, just as it was becoming clear that electricity was going to be a big deal. And the factory was organized around the steam engine. Why? Because the steam engine was the power source, and so you put all the machines that required a lot of energy close to the power source, the machines that required less energy farther away from the power source. You organize the factory around the power source because the further away the machines were, the more energy dissipated. And so the first applications of electricity, of electric motors in factories, took out that steam engine and dropped in an electric motor, and they saved 5, 10, 15% in energy costs. And for most factories, that just wasn't worth it. It wasn't worth to take out your power source and put in a new power source for a little bit of savings. And so even by 1900, we had very, very little adoption of electricity. This is from Warren Devine Jr.'s JEH papers, where the data comes from, interpreted by Paul David. Okay. And so we had this first wave of point solutions where you take out the old machine, you drop in a new machine, but you don't change your workflow. That's what we've seen so far with AI. We've seen these point solutions where we take out the old machine, old process, drop in a new process, and we don't really change anything else. It seems easier that way, but it's been kind of underwhelming. What happened with electricity is we had a second wave. Starting around 1900, people realized that they could reinvent the way the factory worked. Because what electricity meant wasn't just cheap power, but electricity allowed you to decouple the power source from the machines. And once you could decouple the power source from the machines, you could organize your factory differently. Right? You could have inputs coming in one end, outputs going out the other. You could have modular production in the most efficient way to organize the workflow of the parts going in into a finished product coming out. And so around that time, that's when we started to see this kink in adoption and an increase to the point where by 1920, half of households, or in the 1920s, half of households and half of factories had adopted. It was clear in the 1880s, for those who are paying attention, that electricity was going to transform the way we lived and the way we worked. But it wasn't until 40 years later that half of households and half of workplaces were electrified. So we had those between times in electricity, and we hypothesize that we're in the between times for AI. We recognize the potential of the technology, but we haven't figured out how to make it integrate into the organization of the future. We haven't figured out the co-invention necessary to build systems around better, faster, and cheaper prediction. So we have all of these point solutions. Almost all of these examples I gave are point solutions, just like that steam engine being swapped out for the electric motor. Oh, yeah, your bank was predicting whether you're going to pay them back before. Now they're using machine learning to predict whether you're going to pay them back. But they haven't really changed anything else about their workflow. Atomwise predicts which molecules bind with which proteins for drug discovery. Okay, so AI and drug discovery sounds amazing, but ultimately it's fitting into the same place in the workflow that pharma companies tried to figure out, hey, which are the molecules that are most promising? Amazon with a recommendation engine. Yeah, so instead of recommending the most popular thing, like would have been the Book of the Month Club or Columbia House Records, they have some kind of prediction, but ultimately it's still a catalog company. At least they're, and they still, you send information to the warehouse and they ship it to your door. There's at least one industry that has seen this kind of a system level transformation, moving from point solutions to systems, and that's the online advertising industry. So about a decade ago, I wrote a paper, What's Different About Online Advertising? It was a review paper summarizing literature. What was consistent in almost all of the literature on online advertising is that online advertising is better targeted than other kinds of advertising. And targeting is fundamentally about prediction, filling in the missing information of who is this user who's arriving and some information about them, okay? And so the first applications of online advertising 20, 25 years ago looked a lot like magazine advertising. So this is what if you want to advertise in a magazine, this is what it looks like. This is the People magazine rate card. Okay, so if you want a full color page, it's going to cost you $400,000. Doesn't matter what you're advertising. Doesn't matter what the content of the magazine this week versus that week is. There is a fixed rate card. So as part of my dissertation 22 years ago, I sent some information. I went to some advertisers and said, hey, I want to advertise. I want to advertise in Encyclopedia Britannica. What's it going to cost? And they sent me a rate card. Encyclopedia Britannica, run of site, $55. But if I want to target, it's going to cost $65. Okay, just like a rate card, but applied to online. Point solution to the old system. Just in case you think the Encyclopedia Britannica was maybe a little bit backward, DoubleClick looked the exact same. Okay, so DoubleClick had a rate card. If you want to advertise for cars, it's going to cost you $50. They had predictions about what people were looking at. Our cars was $50. Search was only 25. So no matter what, per 1,000 views on the search engine at DoubleClick, $25. But then over the next 20 years, they created an entirely new system with those predictions at the center. And there's all these products as part of DoubleClick, which is only a tiny piece of this entire new ad tech ecosystem that are built around these predictions about a user comes, what might they be interested in? Okay. So predictions at the center, but it's not the only innovation. It's part of an entire suite of innovations, a bunch of new technologies that together create the advertising ecosystem that we see today, the online ad ecosystem we see today. So, okay, so that's one example. It's hard to find many more. Most examples are of the of AI, even where it's working and it's working at scale, we had an old workflow, we dropped in a machine, and didn't change much else. Yeah.
I mean, that's a great example, and I can see how it changed. Say a little bit more about the role of AI in that ecosystem specifically, and how and why that's particularly important.
Okay, great. So, a user arrives at a website, and we need to know something about that user in order to run a real-time auction to figure out which advertisers might want to put an ad in front of them. Okay. And we need to figure out that information in a fraction of a second. Okay. So what do we know? We know the website they're going to, but pretty much everything else we know about the user is going to involve some predictions based on data where they've been before, based on data on their demographics, based on data on where they're logging in from to predict what they might be interested in. And so, the AI is at the center of the targeting, the prediction of who the user is, and then all those other innovations can only work once we have those predictions. There's no point in running a real-time auction for a user in the ad.
Kind of like sorting through all the people.
Right.
Like,
yeah, you have to have a rate card otherwise. So without a prediction of who the user is or some sense of what the user wants, search engines are a little bit different there, but in display advertising, without some sense of what the user wants, this whole ecosystem doesn't make sense, and you may as well just go back to a rate card.
And I should say, are you okay with people if they have like a clarifying question?
Oh yeah,
asking,
sorry.
Yeah, okay.
Absolutely.
So,
okay.
And for those of you who are online, feel free to put the questions in the Q&A function, and I'll sort them out. But we'll try and save about 10 or 15 minutes at the end for just more broad general questions.
Fantastic. Perfect. Okay. So how does this technology, what makes it high potential, and how do we think through what those new systems might look like? So right now, when you make a decision, there's a prediction and a judgment that go on together in your head. The prediction are the underlying probabilities, and the judgment is the relative payoffs, and what should you do with those probabilities? My favorite way to think through prediction and judgment is through another science fiction example. It's the movie I, Robot. It's maybe not the best movie in the history of the world, but there is this amazing flashback scene, Okay, so Will Smith is the protagonist in iRobot. There he is, and he hates robots. And so you can kind of see where the movie's going to go. Why does he hate robots? Well, there's this flashback scene. He and this little girl are driving, and they get into a car accident, and they're sinking into a river. And it's pretty clear that both of them are about to drown. Then a robot comes along and saves him and not the girl. And that's why he hates robots. Now, because it was a robot, he could audit the machine. He could figure out why did the robot save him and not the girl? And the answer is the robot predicted that Will Smith had a 45% chance of survival, and the girl had an 11% chance of survival. And since 45 is more than 11, the robot saved him and not the girl. Then he goes on to say that 11% was more than enough, and humans know that. Well, I don't know about that. That's a statement that a child's life is worth more than 4 times an adult male's life. Maybe we all agree on that. Probably not. But that's a statement about judgment. That's about the payoffs, not the predictions, but the payoffs after the fact. What machines do, what machine prediction does, is it forces us to do this uncomfortable thing of, in the presence of a prediction, what do we want to do? What do we value? What are the payoffs? It forces us to do that in the context of life and death, but it also just forces us to do that in the context of day-to-day. And we're just not used to it. It's not how our brains work. And it's also, this gives us a convenient ambiguity about why we're really doing what we're doing. And once we see the prediction, that convenient ambiguity goes away. An example of this convenient ambiguity is in Flint, Michigan. So Flint, Michigan had a lead pipe, a water crisis a few years ago. I don't know if you remember. And there were these 2 professors at the University of Michigan who built a prediction machine, built a machine learning tool to predict which pipes within the city of Flint were made out of lead. And the machine worked pretty well. So the base rate in the city was something like 20% of pipes were lead. And if they were when they were following these professors' predictions, it was 80% right. And so it seemed like a huge success. The city started using their predictions, and every time, for every 5 times they dug up a lead pipe, or they dug to look for a lead pipe, 4 times it was lead. And that's great, because once you've dug it up, it's pretty easy to replace it. The expense is actually in deciding where to dig. So that saved thousands, if not millions of dollars, and saved people from drinking poisonous water for months or years. But then the politicians got involved, because people started complaining, hey, how come the people down the street, they got their pipes dug up and my pipes aren't dug up? How come that neighborhood has almost all their pipes dug up and no one's getting their pipes dug up in my neighborhood? That doesn't seem fair. We should be doing it systematically, street by street, to make sure that everybody in the city of Flint, Michigan has safe drinking water. And so the politicians said, you make a very good point. So, why are we listening to this AI, to these professors? Let's go street by street, systematically, perhaps starting with my ward, and go through and find pipe by pipe. And so they dug thousands, or hundreds of pipes that turned out to be made of copper and not lead. And so the success rate went from close to 80% all the way down to under 20. And it seems like the story ends there. In fact, the Atlantic, when they had magazine, had a story about it, said a feel-good story in Flint goes wrong, right? It was on the previous slide. But actually it didn't stop there, because once you had that prediction, it was clear what the wrong decision was. This convenient ambiguity of, oh, I happen to be digging on these streets, not because they might vote for me, but because that's where the pipes might be lead. Well, once you have the prediction, you can see that's wrong. You can see what the wrong call is, and a judge saw what the wrong call is and said, you know what? From now on, by law, the city of Flint, Michigan has to follow these professors' AI algorithm. And the success rate went right back up to something like 70%. And once you could decouple the prediction and the judgment, it was very clear what the right call was. And that led to, in this context, a change in power. So how do we think about new systems? How do we go from imagining, so recognizing that, okay, well, so far we have all these point solutions. When implemented, they've been, the companies have benefited, but it hasn't been transformative to system level solutions. How do we imagine that reorganized factory of the future, right? If you go back to the history of electricity, there were a lot of false starts. People thought electricity was going to do all sorts of wonderful things that it just didn't do. There were apparent health benefits to electricity that just didn't come to fruition, right? We knew electricity was going to transform our lives. We just didn't know exactly how. So once step one is to recognize this decoupling of prediction and judgment. Step two is to recognize that what are predictions useful for? Predictions are useful because they help us make better decisions. That's it. And decision making is everywhere. And so I don't know if you've ever interacted with an AI company and you say, well, what are your predictions going to be for? What's your AI for? And they say it's going to provide you with insights. And you say, okay, thank you very much. And you walk out the door, because insights, in our experience, is code for I don't know what to do with the predictions. They should describe specific decisions that the predictions are going to help with, right? And once you understand that, then you can see, well, what ultimately is going to need to happen is a bundle of decisions, because no organization has only one decision. And what's going on in this part of the organization, as the AI gets better and better and better, is going to affect what's going on in that part of the organization. So when we envision new systems, we have to think through what are the goals of the organization? What are they trying to accomplish? This is Seoul Incheon Airport. It is often voted the best airport in the world. It's pretty spectacular. Multi-billion-dollar airport. There's a museum, there's theater, there's massage chairs, great shopping, great restaurants. And this is a shed, right? This, I'm told, is the airport that you guys all want to fly through. Not Seoul Incheon Airport, but this one. This is the private terminal at Boston Logan Airport. This is how the super rich fly. They don't fly in a beautiful airport. They fly through a shed. Why do they fly through a shed? Because no one wants to spend time at airports, right? The mission of Seoul Incheon Airport itself is to ensure smooth air transportation. All that architecture you just saw has nothing to do with ensuring smooth air transportation. It's all a kludge for when they fail to ensure smooth air transportation, right? If you had good predictions, if you knew how long it would take you to get to the airport and onto the plane, then, well, you just walk onto the plane like the super rich do. You only need this architecture because of the failure of prediction. And once you have, once you're really delivering on your mission, you can design an entirely new kind of system. So we start with the mission. What are you trying to accomplish? And then think through what parts of your organization are built not to support what you're trying to accomplish, but because you're failing at what you're trying to accomplish. Another example. So imagine you go to your doctor, and your doctor, looks at your blood work, looks you over, and says, "There's about a 5% chance of something horrific happening to you over the next year. If that happens, we'll send you a check for $500,000. Thanks very much. See you next year." Seems crazy, right? That's exactly what your insurance company does, right? They look over your house and they make a prediction. They say, okay, well, there's some percent chance, we can price the risk. There's some percent chance that something catastrophic is going to happen to your house. And if that happens, we'll give you some money. But they say that their mission is to give you peace of mind against catastrophic loss. Peace of mind isn't, okay, we know that there's this real risk that something horrible is going to happen, but if it does, don't worry, we'll give you some money. Peace of mind would be, well, now that we can predict what's going wrong, we have a good, we can not just maybe price the house, but price the hazards. We know that the reason your house insurance is so expensive is because you're very likely to have leaky pipes or an electrical fire. Well, those are things we can do something about. So with all the sensors we have in our homes now, if we have a great prediction that, well, you know what, $200 of your insurance is because of the risk of electrical fire, then we can put in a sensor for a lot less than $200 that measures that risk and maybe shuts down your electricity if you're about to have a fire. That's really fulfilling the mission. It's moving from pricing risk to a different business model of risk reduction. But that's going to be hard. Most organizations aren't going to be able to do that easily because, if they get insurance, There's the center of power in an insurance company is underwriting. And this whole risk reduction story is all about marketing. And the center of power in most insurance companies is not in marketing. And so we're going to have this tension. And furthermore, the marketing center in insurance companies, they typically get paid by, through revenue. And so why would you want to give somebody a discount because they've reduced their risk? Their sales force is going to say, I don't want that. And it's going to create some tensions within the existing workforces. Okay. Last story in getting from point solutions to system solutions. So I don't know if anyone here has been paying attention to the medical literature. There's an extraordinary number of AI in healthcare papers. It's unbelievable. If you search AI in health, you get about 2 million hits in Google Scholar. This is not Google, Google Scholar. And it's okay. Well, you could do AI to predict this. You can do, you can use to diagnose all sorts of things. You can, maybe start helping with your hospital workflow, with operations, etc. And so, despite all of these seeming solutions, that many of these papers, by the way, do say the machine is better than the human. Okay, so Jeff Hinton 6 years ago said we should stop training radiologists now. It's just completely obvious that in 5 years, AI is going to do better than radiologists, or deep learning, he said, is going to do better than radiologists on reading scans. People pillory him for that. Like, oh, he said 6 years ago that in 5 years the machines are going to be better than human. Well, it's not obvious that he was totally wrong. There's lots of examples of the machine reading a scan better than human. The thing that was missing was that doesn't mean that we should stop training radiologists now. Maybe it means we should start training them differently. Or maybe it means we got to figure out how to, just because the machines are better, we got to think about new systems that take advantage of the fact that we have better machines. So we have this incredible body of research on machine learning in healthcare, and yet, the data says almost nobody is using machine learning in healthcare. This is jobs data, but you saw it in the census. You can see it over and over again. This healthcare is an extraordinarily lagging industry in technology general, in AI in particular. And this is by NAIC, so healthcare is with social assistants. But actually, as of the last time we pulled this data, social assistants had more AI than healthcare, okay, per capita. So let's think about emergency medicine. The mission of an emergency department, the University of Pittsburgh, for example, which they have online, is to improve the outcomes of acutely ill and injured patients through high quality, cost efficient care. So that seems like machine learning or diagnosis is central, in particular triage. Someone arrives at the emergency department, you got to figure out what's wrong with them. So Senda Melanathan and Ziad Obermeyer said, oh, you know what? One of the things that happens when people arrive at the emergency department is they're diagnosed for likelihood of having a heart attack. That is very clearly a prediction problem, and they wrote a whole paper about it in the QJE. And in this paper, they said, let's use a machine learning algorithm to predict whether people are having a heart attack as they arrive at the emergency department. And then let's evaluate it against how the humans do. Okay? And they found the machine learning algorithm did better than humans. Okay? So the humans were right about 15% of the time. Just in case you think it's low, just remember if someone's actually having a heart attack and you send them home, it's a big deal. So conditional on the same number of mistakes sending people home, the humans are right 15% of the time, their algorithm is right 22% of the time. So like a 50% increase. Seems incredible. And the paper is all about the ways that humans are stupid. Okay, that's how it got in. It's all about the different ways that humans make mistakes. Overwhelmingly, if the underlying idea is if someone comes in and they have chest pain, then human doctors disproportionately assume that they have a heart attack, even though chest pain is often not because of a heart attack. And in many people, particularly women, heart attacks don't manifest through chest pain as often. And so the point of the paper was, here's a point solution. It can do better. We can improve current processes. But in that paper, they have an online appendix. And hidden in that online appendix is an online appendix 3. And online appendix 3 provides a system solution. Online appendix 3 says, how does the workflow of an emergency department actually operate? The workflow of an emergency department actually operates, which is that, okay, you predict somebody's having a heart attack. Then you send them for further testing. You send them for a stress test. If it's an old-fashioned hospital, the stress test is on a treadmill. If it's a more modern hospital, it's through scans. You send them for a stress test. That's further testing. It is a stress test. It has some risk because it's putting stress on the heart. That's the whole point. And then if they still think you're very likely to be having a heart attack, they send you to surgery called catheterization. And in that surgery, it's a definitive test for whether there's a blockage, for whether you're having a heart attack. And in the process, they can put in the treatment, the stent. Now, in their online appendix, they say, well, what if those predictions were really good? If their predictions were good enough, instead of say 15%, but imagine they're almost always right, 99%. Why would you ever stress test? To the extreme, if their predictions were amazing, you'd send everybody straight to catheterization if you thought they were having a heart attack, or home. The stress test only exists because we don't know what to do. We don't have great predictions. And the extreme, it's easy, everybody agrees. Now, standard health econ textbook tells you there's two types of decisions in medicine. Okay, there's two core decision makers. There's medicine, the docs, who make a patient-by-patient set of decisions. So a patient comes in and the doctors decide diagnosis and treatment. Okay, and then there's the administration who decides on the resources to make available to medicine. Now, at 99%, the administration agrees, well, this stress testing, that's a waste of resources. And the docs agree, you know what, on this patient, I don't need the stress test. But there's a place in the middle, somewhere between 15 and 99%. If you take the numbers in their online appendix a little too seriously, you get to this place in the middle where the administration wants to get rid of stress testing, but the docs don't. Something around 40 or 50%, the administration says, you know what, there's an opportunity cost to this. The resources that we're spending, the space that we have in our emergency department for stress testing would be better used and would save more patients elsewhere. Where the docs say on a patient-by-patient basis, sometimes I actually want the option to be able to have the stress test. And so we have disagreement in terms of thinking through, once we get to the extreme and the predictions are amazing, then often things are easy. But we're not going to get there instantly. And the path to getting there is going to lead to this kind of disagreement between the different arms of decision makers within the hospital. There's no easy solution to that because it's going to require some new processes, because the administration could say, you know what, I'm in charge of resources, forget it, you don't get the stress test. Okay. The doctors won't take that line down. They'll say, but they'll fight back. They'll bring in patient rights group. They'll do all sorts of stuff. And so we need to think through a new process for it.
Can you say a bit more about why they're disagreeing? It's not different data by assumption, it's different incentives, different goals?
It's different incentives. So the doctors tend to focus on patient by patient. For this patient, I'm going to want a stress test. And the administration tends to focus on the, we'll think more, at least on these models, of the opportunity cost of having this here. Because they won't be thinking patient by patient. In the emergency department, they'll be thinking, well, for the patients who are having heart attack in the emergency department, if we take this away, yeah, they might be a little bit worse off. But those resources could be better allocated to other patients.
And they don't weight those other patients in their decision about this patient.
That would be, yeah. And I think the standard in medicine is you focus on the patient that you have and don't think about the opportunity cost for other patients. And that's part of why the difference in resource allocation is useful. Yes.
From a the doctor's point of view, the reason you have the stress test is that your initial data was not good enough.
Yeah.
You need to take more tests until you're good enough. But if your initial step was better, you probably would pick something different than a stress test, because something much simpler would get you that rest of the way.
Oh, I see what you mean. So,
you
okay.
redesign the process with a different way of collecting data.
Yeah, absolutely. So that's going a step beyond the data we have in terms of how they described it, but absolutely, it's the so at 99% is easy. You don't even need the test. But at 40 or 50, maybe there's a way to get to a point where it's a less expensive test and a less costly test than we have here. Absolutely, absolutely. And that's part of the challenge that we're going to have in thinking through what's, as our predictions get better, how do we reinvent systems to take advantage of those better predictions? Okay. So we can even go a step further, which is going toward your point a little bit, which is that, well, once we have great predictions, why start at triage? Why don't we start when the person calls 911? So a person calls 911, standard practice in many cities is to send an ambulance, a police car, and a fire truck. Okay. That's implying that we have no prediction, no idea what might be wrong. Well, if we had a good prediction of what's wrong, we wouldn't send all three. We'd send one, but then we need some resources on which one And we need to make sure there's enough ambulances to get there, enough fire trucks. We need predictions, and we need to understand the resource allocation across the city in terms of paramedics. Okay. But and then with enough sensors, we could go beyond, oh, let's just send an ambulance. We could say, well, let's send, this person's having a heart attack. Let's send an ambulance with equipment designed for cardiac arrest. And let's send a paramedic who's trained to help somebody who's having a cardiac arrest. Okay. We're not there yet. Right now, we don't have any specialization. With enough prediction, there'd be enough population density, there'd be a benefit to doing that. But doing that requires a whole bunch of other things. Now we need to think through the resources. What belongs in the ambulance? How do we train paramedics in the right way? Do we even want to call them paramedics anymore? Are they actually just docs who are going directly to homes? Thinking through all these new changes is not going to happen next year. And so these are the kinds of system changes. The distance between where we are and the other side of the between times is probably bigger in healthcare than just about anywhere else, because there are so many different moving parts. Training takes so long that getting from here to there is hard. And we need to think through, right, innovation in who has decision rights. So is this, medical administration is within the hospital, but you can go beyond that and think about the city level or the location level in terms of allocating paramedics, and to the medical education level in terms of, well, wait, if machines are doing prediction, do we need family docs at the center of the healthcare system? Or is there somebody else who should be there? So there's all, moving back and back and back, there's all sorts of changes in decision rights. That also is going to require a lot of regulatory change. For good reason in healthcare, for very good reason, regulatory change is cautious because mistakes are a very, very, very big deal. So in order to get there, we're going to need to think through not just regulatory change, but processes that allow us to be both risk averse and take advantage of what the technology can do. And we'll probably, to your earlier point, Sandy's earlier point, we'll need to build new medical practice. We need to think through, okay, well, wait, if our predictions are pretty good, but they're way better than they used to be, but they're not quite 99%, is there something we could do that's not a stress test that can move us over the needle, that doesn't take as many resources, that we'll figure out whether we should do catheterization or not? Yeah.
Do you have a hypothesis about the kinds of organizational, institutional systems that are more likely to adopt that? I mean, your earlier example, there's some doctors that have a particular focus and set of incentives that they get very honed on that. Others who have more system-wide.
Yeah.
There's a lot of different kind of healthcare systems in America, not to mention globally. Right. Do you have can you say something about which ones you think would be most likely to make those kinds of systematic changes? Do you have any thoughts on that?
Well, okay. Yes, I have lots, but I'm trying to think about how to make them succinct and robust. Okay. My first instinct, trained as an IO economist, is to look for places where there's competition and lots of entry. Okay, that's where you'd think there'd be opportunities. As long as so for some of these changes, competition and lots of entry are going to work. There aren't a lot of places within healthcare with competition and lots of entry, so that's going to be a first order challenge, especially at the hospital level. But then there's this other challenge that a lot of these require coordination at scale. And so coordination at scale, like, in terms of thinking about, reimagining emergency medicine, that's beyond the hospital. That's going to be at the region level. That requires governments that are both interested in making the change and and willing to do so. And that pushes in the opposite direction, which is a very centralized system. And so that's very much me being the economist and saying on the one hand and the other hand, but somehow not like the in the middle of lots of market power, but no incentives to really, no ability to coordinate at the region level is going to be sort of the worst of both worlds.
It seems like broadly optimizing dynamically as opposed to statically, one that's willing to be flexible and change around. And you can see either of those making the case for it.
Absolutely.
Maybe a big HMO like Kaiser, they could do
Yeah.
experimentation.
Absolutely. Yeah.
So one of the most exciting things is that CVS or Walmart are now putting doctors in there for these sort of immediate things. Basically cut out almost all the things the hospitals see. Of course, they're market driven and agile. And then you combine that with things like smartwatches, which give you those extra bits so that you can make better predictions and the leadership in the insurance industry think this is gonna sort of really change the game. Right?
Yeah.
Right.
And as I understand it, a key to that is the doctor doesn't need to see every patient in the same way that they used to. They can essentially, you have the doctor on site as a supervisor, but you have these diagnosis machines and other medical professionals who can really help.
And there's a
But that's
comment
gonna require
online,
new
if I
training.
can, or
But
question.
also,
Yeah.
a CVS has much lower overhead than a hospital,
Yeah.
and their revenue stream is not just from the medicine, it's from you buying chips on the way out.
Okay. I think where the margins are there, but that's okay. Question online.
Eric online also notes that what's not taken into account is the deficit of trust of AI predictions unevenly distributed among different populations, including gender and race. How would the patients react?
Yeah, that's an excellent point. So all like that at an abstract level, I would view that as part of the co-invention of thinking through how do we build new kinds of AI systems that people are going to trust. It's not the narrative. There's a very common narrative that we need things to be explainable and interpret the AI. Personally, I think that's a misleading narrative because for two reasons. First, from my understanding, this is an interview with Ziad Obermeyers, who's a doctor, but was one of the authors on that paper. He said, we have no idea why particular drugs work. Like once a drug gets to stage 3 clinical trials, we think it's going to work. And a lot of them do, and a lot of them don't. We have no idea why, but we run the trial and we learn from the experiment what works and what doesn't. And so it's not a statement of, oh, we can explain it. Yeah, we can explain it, but we can kind of explain anything. It's the underlying, oh, we actually did the best we can statistically a clinical trial with treatment and control group and saw if it worked. And so when we think about the machine learning tools, the push toward explainability, there's a worry that it's not necessarily going to be clinically better. And there's also a worry that there's a lot of parameters that can go on in these machine learning models. And so I wonder to what extent some of this explainability is a fiction. So there's thousands of parameters. Yeah, we can say here are the 3 most common things that lead to a prediction like this. But maybe for you in particular, it's a 6-way interaction term that we didn't anticipate. We just don't have that in the way the systems are set up. And so when we're moving to explainability, I worry that maybe it will build trust to the question, but it will build the wrong kind of trust because it's not real. Unlike with other systems, which are still imperfect, we at least have the trial that the randomized trial.
Trust also could be part of the story behind your lead pipe story, where people are saying, wait, some people are getting dug up and others, and you're looking at the data and say, well, it's because that's what the machine learning system using its objective criteria. Other people may be skeptical that that's the reason that it was done.
And there's only so transparent you can make the systems. And so what you can do, ultimately the transparency is going to have to be through the outcomes. And sometimes it does shine through, like it did in the lead pipe story. 80% versus 20% is a big difference. And so it's obvious what the right call is. And sometimes it's going to be harder. And we need to absolutely agree that we are not there yet on building systems that people trust in many cases.
Well, in some ways they're more opaque, right? Than they're hard for even experts to understand what's going on inside.
Absolutely.
So we have about 10 minutes, so I don't know whether you have...
I'm done.
Oh, you're done, okay.
That was my second last slide.
Okay.
The last point was, we got to get from point solutions to system solutions, and that's what we're trying to do in the book.
Well, great. Let's open it up to questions. There's also some online, but I'm going to, for those of you in the room first, how about right up here?
Probably unshare slides. Yeah.
Yeah. Hi. Thank you so much.
Thank you.
My name is Irini. I'm a postdoc in the Department of Genetics. So my question is maybe a bit relevant to people trusting it or not. I think it is a great tool, and I'm sure as humans evolve, there will be more and more great tools. But I think it is also within our nature to use several tools, not in the most productive or nice way, right? You can think whether it's nuclear power or social media, all great tools, but they can be used or have actually been used in detrimental ways. So my question is, what do you think the checkpoints would be? Because I don't have a worry about actually, the quality of the work that will come out of using this tool, but how can we also regulate it that is not being used for in detrimental ways?
That's a good question. So I think we're figuring it out in lots of different places, but I'm very optimistic about this technology, but I'm optimistic about the technology, I think fundamentally because I'm pessimistic about humans. And what do I mean by that? So like the classic story, AIs are biased. So this is one of the examples of where people are worried about using machine learning tools for hiring, because AIs are biased in hiring. And so there's good reasons to worry about that. There's lots of evidence that if you use AI as a point solution, which is, hey, we had humans in our HR department who were hiring. Let's take those humans out of our HR department and predict who they would hire. And it turns out those humans would discriminate against all sorts of people. Okay, and so when we have an AI predicting who the humans would hire, the machine discriminates. What's nice is we can actually audit the machine and find that out, and we have been. But the solution too often, in my view, has been, let's go back to that human process so that the prediction and judgment are bundled in the person's head, and we have this useful ambiguity about whether we're really discriminating or not. So what we're seeing so far when we're doing point solutions where we take out the machine, take out the human, put in the machine, are machines that are no better than the human, that do it faster and at scale, but are no better than the human. But because we can recognize those biases, we can improve them. And there's a growing body of research on strategies for hiring and for credit scoring and other places where you can deliberately try to reduce bias. So as long as we think, I said I was pessimistic about humans, but like as long as
Because I'm pessimistic about humans and how we use. So I think we're definitely on the same page.
So, as long as the scrutiny that comes with machine predictions that provide numbers lead to a reduction in bias because people want to improve them, that kind of a system, once we think through how to do the system change, it can be better than what we had before.
Do you think it has to be like a quantum improvement or just a little bit of an improvement?
So I think
I
eventually,
agree with
my expectation is there's some under different you can't have a machine that's fair under all definitions of fairness. So that's going to be mathematically impossible. But they can be a lot better, a lot more fair than whatever human systems we have now. So I think
or at least you get to see that you can be. You make them visible, like you said earlier. You can decide, okay, what trade-offs I'm going to make.
Exactly.
Maybe that's uncomfortable, but you're sort of forced to say what the trade-offs are you're willing to make.
So I'm on the quantum improvement side rather than that. I don't know exactly what the metric is for that, but just I expect in time the resistance to these are going to be from the people, not the people who worry about discrimination, but the people who benefit from it. And the best example we have from history so far in that, or at least to my knowledge, is in Major League Baseball. About 20 years ago, they brought in a machine umpire that would predict balls and strikes. If you think about it, it's a little bit about baseball. It's crazy that we have humans calling balls and strikes. This thing's going 95 miles an hour over something this big, and a human saying whether it's in a box this big. That's insane. But machines do that pretty well, right? And so they brought in a machine to predict balls and strikes. And the umpires didn't like it, but no one really cared. Maybe they did, but my sense is nobody really cared. But the star players hated it. Why did the star players hated it? Because the machines were the umpires, the human umpires, were biased in favor of the star players, right? The star hitters had these really big, really narrow strike zones, and the star pitchers had these really big strike zones. And so to the point where the two who hated it most were Barry Bonds and Curt Schilling, who were arguably the two biggest stars at the time. And Curt Schilling took a baseball bat and smashed one of the cameras because he hated it so much, right? So this is just as we start to see machine, because he's a jerk. But okay, I don't know about that. That's not on the record. That's not on the record. Okay. Yeah, I know. But this was 20 years ago, before we knew what we know now. But like the star players hated it because they benefited from the bias. And I think as we start to think about not just taking out whatever human process we had and just dropping in a machine and leaving everything else the same, but trying to think creatively about how we can reduce discrimination. And actually, a good chunk of Sendhil Mullainathan's work has been around that. And Lindsay Raymond, who's one of your postdocs,
talking to her about an hour ago,
about thinking through how to reduce bias by essentially investing in exploration. So if you don't have a good sense of
Reinforcement learning system that explored, not just exploited, versus a supervised learning system that was just taking the data. Yeah.
yeah,
I mean, let me just get a question in from online because it's sort of on. It's actually kind of more of a comment than a question. As the,
okay,
as the
best kind.
It goes, yeah. Really appreciate the talk. I wanted to note that in some applications, it looks like the trend might be to recouple prediction with the decision, as in people analytics, workforce management systems, and that automate the hiring and firing decisions. We were just talking about that. That's why I'm bringing it up. Here, the concern is that flawed as humans are, the total automation of management is not the solution, that we need to keep a role for humans. So I mean, I think you kind of addressed that, but feel free to.
So I just like, so far there is a difference between like prediction technology and automation. So the AI technology sometimes lead to automation and sometimes don't. What automation is when you can pre-specify the judgment. So when you can when you can specify in advance, hey, once you have a prediction, here's what you should do with it. That's when we that's when we get automation. And so what automation does is it scales some people's judgment. That might make us worry, or it might create opportunities depending on how we think about scaling some people's judgment. So there was this like story a little while ago. It wasn't quite true, but it was in the press for a while, that Amazon was automatically firing their warehouse workers. Like you had some score, and at the end of the day, if you fell below a threshold, you got an email that said you were fired. That didn't happen. But even if it did happen, like just as a hypothetical, what would that mean? Well, that's not a statement about a machine deciding who to fire. That's a statement about someone at Amazon headquarters deciding they didn't trust the managers in the warehouses to figure out how to conduct HR decisions. And so it was a way for the management at headquarters to scale their judgment and essentially take power away from the managers on the ground in the warehouses. So when we're thinking about machine decisions, like remember, at least as long as we're talking about prediction machines, as long as we're talking about machine learning and the technologies we have now, there's a human behind it, thinking through what the payoffs are and thinking through thresholds, and those are the set of decisions. They're ultimately the decision makers, and they're ultimately responsible.
Great. We're almost out of time. Let's give the people in the room. I think you had your hand up for a while, so go ahead.
Okay, thank you very much for the talk.
Thank you.
On the note of history and analogies, do you think that perhaps the rise of statistics would be a more appropriate metaphor because it relates to numbers and decisions and the actual quantification, whereas here it's often a matter of manual labor in the steam engine, and as Eric has written about previously as well. Whereas numbers is actually, there you see the decoupling between the goals that we want to accomplish. For example, in medicine, using qualities, who's to say what life years are worth more than others, for example. So do you agree with that?
Okay. So is it, sorry, I don't quite understand the question. Is it that statistics is a good historical example?
Yeah.
Okay.
Yeah, to explore the tensions and the decoupling.
So I actually think something a little bit different. I think statistics are super, super important, but rather than an historical example, we could call the technology we have today statistics, okay? And just say there is a suite of technologies that are around the at scale and effective use of data that together represent a general purpose technology that underlie these changes. And right now, we're still applying point solutions, not system solutions. So like I don't know when we want to think about the start of that stats change. Maybe it's 200 years ago. Maybe it's 10 years ago. It depends on how you think about it. But absolutely, I think the recognizing the power of stats and it was very. My co-authors and I had a tongue-in-cheek argument about whether we should call this book Computational Statistics and Power, but we decided not to, but fully agree with that underlying framework.
Bring it up is because there's all this hype about AI, and then that begs the question, what's really new here, right? And oftentimes it's the deep learning that is hard to actually, find a reasoning or some kind of evident transparency behind why a certain decision was made. So perhaps, do you agree that's a difference in kind?
Between like good old-fashioned stats.
Yeah.
Yeah, maybe. I think it's a matter of degree. I think for most people, understanding what's going on in a regression is also pretty hard to get your head around. So that's a fair
So we're just about out of time. Let's do maybe two real quick questions. Three real quick questions.
Okay.
So go, and you can do what you can to answer them.
Okay.
Just do it.
Yeah,
Just
we'll
take
go
the
the questions in a row. And
Yeah,
then
yeah, go ahead.
Thanks for coming. I'll try and shoot this at as quickly as possible. I want to use your medical services example to ask a question about where demand is going to come from. Where's the demand driver? So in medical services, you really don't have top-down mandates for the adoption of the best technology and innovations, right? The state level just does not happen, right?
Yeah.
Very rarely do you get that. When I think about all the industries that you delineated at the beginning of the talk on one of the earlier slides, I think, oh my gosh, there's not going to be a mandate-driven demand for any of that. So where's it going to come from? It's going to come from consumers. That's very, very difficult. The CVS example, it comes from an
It's got to be
intermediary,
a question.
right? So I guess the question is, for the industries that you think are going to adopt AI innovations earliest, where's the demand going to come from? Consumers or somewhere else?
Quick question.
I wanted to ask you whether you think that the type of systematic change you're talking about might come from generative AI models, because it looks like it might be happening in software development.
Okay.
And you have a really quick question.
Where do you think these predictions or AI should not be implemented in the system?
Not the info.
Okay. Ooh, okay.
All right.
That one we're gonna have to wait for later because it's a really deep, hard question to answer. But in terms of thinking through where the opportunities are, like it's thinking through or rather than industry by industry, I think it's better to think it through organization by organization, and ultimate need by ultimate need, and think through is that industry, is that company delivering value based on what they're trying to achieve, or are there all these kludges based on bad prediction? And that's I think where to look. Generative AI, so far everybody's talking to them. Their applications are still overwhelmingly point solutions, and that makes it's kind of depressing for we're gonna replace graphic designers and we're gonna replace computer programmers. But like clearly, to me anyway, there's nothing screams more for creating a system solution, like, well, now we can do graphic design at scale. Now we can do a different kind of programming than these generative models. I think they're very exciting for thinking about how to get here. I think that's a good place to stop.
Well, thanks. Yeah, I'm sorry we're out of time. So much interesting stuff. Thank you so much, Avi.
Okay,
We really appreciate it. And on sale tomorrow at Amazon and bookstores around the world. So please buy that.
Yeah, good to see
Next
you
week,
too.
please join us on December 5th, actually, when our speaker is going to be Jan Leng, who's going to be talking about learning network structures from
That would be
behavioral data.
wonderful.
So see you on December 5th. Thanks very much.
I'm heading